let's first understand about the structural drawings. What are they? What are the general components of it? Now see, the reading and interpretation of structural engineering drawing is much underrated skill. A skill that is often not taught but learned through the frequent exposure to structural engineering contents and a drive to fully understand them. In simple form, a structural drawing can be defined as any drawing consisting of plans or set of plans and details explicitly showing how a building or structure will be constructed. See, every structural drawing produced must achieve one purpose. It must effectively communicate the engineer's intention on paper. This is fundamental and very key for any drawing issued by a structural engineer. From a very complex general arrangement to a simple sketch made on site. The structural engineering drawing must be a well-defined and clear of jargons. Because see, ultimately your project execution is totally depend or whatever the design and analysis you perform, each aspect of your analysis and design will be represented on site. So that is very important. You need to understand how major role your drawing play on site. So let's understand what are structural drawings and how to read them. So structural drawings are series of pages which explain and illustrate the structural design intent of a particular building or structure. It can be steel or RCC. Now the aim of a good set of structural drawing is to provide the reader with enough information on site so that the team on site or the contractor can effectively execute building of a structure on site. Now to construct a building, many disciplines need to be coordinated, not just the structure and architect. A set of structural drawings are usually read along with the drawings from the other discipline as well. So it depends on the category of the structure, which category of the structure you are designing, whether it's a residential building, commercial building or the industrial building. The same implies on the steel structure as well. Now depending upon the category of the structure, various categories of discipline may involve in that particular. Now let me just give you an example. Let's say a mechanical discipline. So ducts for heating and cooling, ventilation and smoke system, in that particular this discipline will require. Similarly, in case of the hydraulic structures, sewer, hot and cold water supply, fire sprinkler system, etc. that has to be decided by this particular discipline. High and low voltage power, lighting, etc. will be decided by the electrical part. Right? Vertical transport, lift, elevators and dock levelers in case of the industrial building, right? To movement of the goods through the truck, right? And ultimately civil, that is road and pavement details as well as storm water drainage. So all these disciplines play an important role in your depending upon the category of the building as well, right? So you need to understand all these components first. Now remember one thing, structural drawings are not to be confused with the architectural drawings. These separate drawing sets provides very different pieces of information. So you just need to understand the difference between the architect and structural drawings, right? So in general terms, if I talk about the difference, structural drawings show the detailed information on the building elements which provide support and stability to the structure, including the material, strength, its grade and reinforcement, while if I talk about the architectural drawings, they provide the detailed information on the building aesthetics and usage such as colors, patterns and finishes. Now let me just give you an example. Let's say for a load bearing column which is shown on both the structural and the architectural drawings. However, the information provided for that particular column between this two set of the drawing is quite different, right? So if we talk about the architectural drawing part, the dimensions and appearance of the columns are important to the architectural of the building. So information such as dimensions, either it can be length, width or diameter in case of circular column, and appearance, paint color if it's a painted finish, or details on the materials if cladding is required. So all these are informations are related to the architectural part. Now for the same column, if we discuss about the structural drawings, the strength and stiffness characteristics of the columns are most important information. Let's say grade of the concrete, which will be mentioned in your structural drawing, right? Also category of the column, let's say whether it can be a concrete column, steel column, or it can be a timber column, depending upon the architectural requirement. And reinforcement. So in case of the reinforced concrete column, the quantity, size and grade of the vertical reinforcement will be the requirement, right? So that's how you can differentiate between architectural and structural drawings. So let me take you to one of the example. See, so here is an example of a particular building floor which is illustrating both the categories. You can observe this particular one is the architectural drawing, right, where all the different categories of bedroom sizes, kitchen and the general arrangements are shown with respect to the plan dimensions, right? Also door, windows and other components are provided over here. Now for this particular same floor, if I talk about the structural part, right, so let's check out this. So here you can observe for the same floor the slab detailing is provided. So this is the part of the structural drawing where we have illustrated the one-way and two-way reinforcement detailing for each slab with the reinforcement detailing and beam schedule, so that on site this particular execution will be done based on this alternate bent up bars for the slab part, right? So that's the basic difference. So if I talk about this one, right, you can see that the architectural drawing goes into much more detail on the look and usage of this zone, right, with specifications on the, let's say, toilet locations, title, doors, windows, kitchen area, so on. So all these elements are non-structural, so they don't appear at all on the structural drawings. Now if we talk about the structural drawings, the structural drawings appears to have a bit more going on in this area with the slab thickness, reinforcement detailing and other additional parameters like sunk slab and the other details, right? So by all these detailing you can understand the difference between the architectural drawing and structural drawing, right? I have provided you one example over here. This is the sample of the architectural drawing, and for the same building we have the detailing part in terms of reinforcement which was developed by the structural engineer. Now let's move to the further. So as I said, it will depends on the category of the building, okay, and as I category of the building, as currently I have give you a demonstration of the RCC building, right, that one was the residential, but let's say if we have the industrial RCC building, then in that particular case all these other disciplines like mechanical, hydraulic, electrical will come into picture, and for that particular you need to refer all those detailings as well which we have earlier discussed. So keep this particular thing in mind. Now let's move further. If we talk about the, let's talk about the general drawing elements, right? So see, these are the common points like grids, title page, revision box, logo, title, scale. All these parameters will be the common point in a particular general drawing, whether if you consider it as a structural drawing or the architectural drawing. In both the drawings this particular detail will be the common one which will be included. So if we talk about the grid part, reference grids are like the glue that ties all of the engineering and architectural drawings together. They provide reference points which helps the reader to identify the same locations on each discipline drawing set. A row of grids following sequential numbers, for example running horizontally and vertically, right? So let me show you that particular part as well. See, these are the grids provided by the architect, and based on the dimensions which are provided over here, we will follow the detailing part in our drawing as well, right? So in order to develop this particular detail, we require the architectural drawing input as well, where the column orientations, distance between these two columns, grid to grid dimensions, orientation, everything matters, right? As you can see, this particular building is quite with the irregular shape, right? So based on the northing, you can see the road details are also provided over here with respect to the plot area. So all these detailing matters. Then we have title block. Okay, so a title block is usually included on every drawing in the structural drawing set and all other discipline drawings as well. Okay, then revision box is also one of the important parameter. This portion keeps track of the revision history of that particular drawing. Here you can see the revision number, letter history, and a brief summary of what the changes were done in the past with respect to the schedule. Then consultant company logo. It may include the organization's logo, address, discipline, and professional registration number. Then north point indicator, which is one of the most important point. Now in case of the floor plan, this shows the orientation of that plan in relation to the true north. Now this is generally left blank for the detailed drawings, elevation drawings, and general north drawings. Then it can have the name of the drawing and client as well. Also drawing size and scale details. Two pieces of information: the indented drawing sheet size and the scale. The drawing sheet at when printed at that sheet size. So that is one of the most important point over there. And we have few general notes which includes the common instruction that needs to be followed on site. Let's say concrete covered grades, specification related to the reinforcement detailing, foundation depth, lap lengths, etc. We will go further much into detail with the example of a particular drawing. All right, now let's discuss these are the few subsets that will be the part of your structural drawing, right? So starting with the general arrangement, it has sections, elevation, structural details, and the general notes, right? So let's understand every component one by one. Now if we talk about the general arrangement part, so the general arrangement of drawing can be equated to the architectural plans, right? But in case of structural drawings, they hold the information on the size and the position of the structural elements in the respective plans. So the GA is very key to where sections through the structure are taken and presented. They present useful information on the elements in the structure, such as the walls, concrete columns, beams, voids, floor slab, etc. Right? I have just shown you one of the drawing for the slab over here, just to give you an idea, right? So a typically structural drawings normally includes GA for the foundation, floors, and roof. Now see, here I have just represent you the what you can say the slab drawing, but it can have the foundation drawings as well. Then section and elevation. So a section is a cut or slice through a structure, usually taken in order to describe the interface between the structural elements. Now see, elevations are the side view of the elements in the structure. Now they are often confused with the sections because just like sections, they are a cut through the structure showing the vertical plane. However, an elevation is at very face of the element that is being viewed, and the purpose of an elevation is to illustrate the flow and interaction between the vertical elements and horizontal elements of the structure. I'll show you few example further with respect to that in the upcoming part. Then I have discussed the structural details part. Then we have the general notes which will be specified in the drawing, that also we will discuss further in detail. Now let's discuss about the connotation part, which are the most important part of the drawings. Let me just take you to that particular. Okay, so a typical structural drawing consists of many text symbols, right, and nomenclatures. Now I will discuss few of them. Later on I can guide you with few of the examples. Let's start with the detail marker, let's say. Right, over here the detail marker is used to show the information on the GA to tiny or not visible on plans. It is usually denoted with a line pointing to a circle where the detail is being taken. Right, over here I have provided one example, and the lower part of the circle contains the drawing number or where the detail is drawn, like this. Similarly, label marker. So the label marker is used to describe the level of a GA from a reference datum, and it is denoted by the box holding the label, like this. It's a sample example. Now depending upon the various consulting firm, this particular will vary slightly based on their standards. Okay, so basically it's this particular point also I'll show you with an example. Then we have the section mark. A section marker is denoted with an arrow showing the point where a cut for which a section has been taken and its orientation as well. So there is usually an accompanying arrow showing the extent of the section. Okay, this one you can observe over here. As in the detail marker, the lower part of the circle holds the drawing number or where the section is drawn. Then similarly we have the elevation marker as well. Okay, it is used to show an area of a GA that is being elevated, where an elevation is on a grid line. They can be used to match the reference. Right, let's say if I talk about with this respect to this number, right, so this mark is for an elevation on grid line number 5. Then we have steps marker. Now the steps marker is used to identify the lines at a change in level, and they are normally identified by adding sectional hatching to the plan. Okay, so these are few important points you need to understand at the initial level. Other symbols I have also specified over here. You can check out this for the section elevation plan floor thickness part. Okay, if we have the cutouts or void, then this one is particularly for your span. Okay, either in the one way, let's say if we have the grating, so this will give you the direction in which you have to lay down the grating parts. Okay, I'll show you this one as also with an example. So let's understand this. So let's say this particular is one of the framing plan from the industrial structure where RCC and steel both are mixed components. You can observe for this particular here we have the RCC beams, and here there will be a RCC slab in slope in this direction. And if I talk about the grating part, see for this particular grade, you can observe the grating span is specified over here with this particular arrow, right, and the grating hatch is also provided. So you can identify that for this particular floor there will be grating, and *1 *1 and other elements means the beam numbers are highlighted with the certain annotations like *2 *4 likewise, right. So they can identify *1 is what. So basically *1 is ISMB 150, sorry, ISMB 125. PC stands for pin connection and MC stands for moment connection. So that's how they have indicated in this particular steel structural drawing, right. So I hope this is sufficient to understand all these parameters, right? Similarly, we have the drawing scales and various categories of lines as well, that you need to understand what is the meaning of the continuous line, dotted line, or line with a specific thickness, right? So here I have specified the detailed description over here as well. You can check out this. Also, then this particular, the revision cloud, which is also one of the most important part of your drawings. Okay, so they are very natural in the design and construction, as you may have few revisions, right? So that revision needs to be followed by the revision cloud, and it has to be marked with R1 R2 if you make any changes, right? Another form of the cloud is the abeyance cloud. Now this indicates a section of the drawings that is on the whole of which the information contained therein should not be referred to or digested. Typically, this particular cloud appears because outstanding information and or confirmation from the other members of the design team is yet to be available. Okay, so this particular segment is also one of the important part you need to take care. Further, we will check out few samples also regarding the drawing to make you aware more, and I will share a few tips how you can improve to read your drawing skills. Stay tuned for more updates.